So our treatment so far of BJT amplifier circuits was restricted to the DC domain, okay, or the direct current biasing, okay, which means the setting up of the DC parameters, those that we have solved previously in great detail, all the BJT DC currents and VCE, okay, IE, IC, IB, and VCE more to ibang solve na to previously. So now, let's put things into a more larger perspective. How can those parameters be useful to us, knowing na in actual di naman kaya nato ginamind atong cells with those parameters. Now again, in actual, technically dili naman to gina-solve ng mga kuan because when we try to acquire or purchase an amplifier na may mga parameters na already given, no, or already stated in the specification sheets, no? So those numbers or values that are stated in the specification sheets, those were obtained using the values that we have just computed, no? But what particular AC parameters then uses those DC values? Okay, so for us, the more practical, no? The more practical parameters are what we call the impedances and the gain. Okay, or specifically in AC analysis, we are more concerned with the impedances, namely the input impedance. Have you heard of this term before? The output impedance. Kadong naman nga term before class, impedance.
Wala pa, sir.
Wala pa. Medyo synonymous na siya. Synonymous lang. No? Synonymous to resistance. Okay. So when we say impedance, it's more of an AC domain na resistance. So if our impedance does not have an AC component, no, wala siya reactance specifically. Dito may circuit supposed to be na tumalan. Impedance and resistance are equal, no, if wala AC no component. So impedance is synonymous to resistance. That's why usually we denote impedance in a circuit as a resistor still. Although na siya sa resistance. So we have the input impedance, output impedance, and the gain. So these AC domain parameters are also the characteristics of our amplifier that is of more importance to us, no? More important, has a more practical value. Okay? So I don't know if you remember in our very first meeting, I think naka-mention ko systematic na approach to learning electronics, which is also useful to learning any particular subject in engineering, systems point of view or systematics approach. Okay, so supposing this is a system, when we say this is a system, it doesn't really matter to us what is inside our system. What is more important is how it reacts to external given input and what are the output values or output signal that it could generate. Okay? So more good po I don't know if this is exactly synonymous to you, Pero magod gyapon nig ka ng, let's say for example, engine, no? Engine. So you only want to know what is the capability of our engine, pila iyang fuel consumption, how much iyang efficiency, no? How much iyang torque, and all those stuff without really knowing what's inside our engine, no? How what is the shape of the gears inside, no? Kung sa iyang mga inner workings, no? We may not necessarily need to know all those stuff. So the same gap sa electronics. Example, we have an amplifier that we have just designed, voltage divider and amplifier. Of course, we know ang voltage divider is or looks like this on the inside, diba? Ma'am nato na learn magulang yun. That's what our voltage divider amplifier looks like. But if we take a systems approach to learning electronics, we do not need to know all those stuff, no? We do not need to know that it is a voltage divider na amplifier, no? All we need is these three: the input impedance, the output impedance, and the gain. These three will sufficiently characterize our system. And in this case, our system is an amplifier. Try to good out class, no? Wala lang, if na may opportunity, try to look into specification sheets of actual amplifiers. Kaning tulo ka parameters will be in the front page good, or siguro sa second page. Kung ang front page is ang itsura sa atong amplifier. Nagid ni permi kaning tulo: impedances and the gain, input impedance, output impedance, and the gain. So this is important to us, these three, because these are the only parameters that we need for us to really use our amplifier. No? So how will we use our amplifier? Maybe we will connect our amplifier to a source, or other term, not as a source. Source mo siguro, no? Maybe it's in the form of a sensor, or it's maybe a microphone. Ang atong load, we connect our amplifier to our load, maybe in the form of a speaker. And a speaker. So if yan na lang atong gusto, we do not need to know pilang IC, pilang IB, pilang IE, pilang BCE. No? All we need to know is the impedances and the gain. No? That is of more importance to us. Pwede nga na, no? We could use our amplifier like that. Or maybe we will connect our amplifier to another amplifier. Maybe this is an intermediary amplifier, amplifier 2. We'll connect it to amplifier 1. And in turn, we'll connect amplifier 2 to another amplifier 3. So each of these amplifiers, technically, they have their own purposes. No? But right now, let's just say that we could connect amplifier 1 to amplifier 2 and amplifier to amplifier 3. And that. So if we'll perform one by one DC analysis to each of these amplifiers, no, medyo taas-taas na siya nga computation. It's possible, of course, so it will take us some time, no, to solve for those values. But if given na, no, if already given ang impedances and ang gain, so there's no need for us to perform all those calculations. So this is important, or a systems approach to learning electronic systems, electronic devices, electronic circuits is important to us, so that we can directly use the system in question, connect it to any system also, without us needing to know what's inside our system. I think this is also useful for any kind of system, whether electronic or not. No? Pwede ganit na, if this is an amplifier, so this is an electronic system, electronic in nature. we can connect it to an electrical system. Any system that does not contain semiconductor values. We could directly connect it to any mechanical system. Of course, with proper interfaces, but it's possible. It's possible that you could connect our electronic system to any other system, as long as we take a systems na approach, systems na point of view. So, balik na dire. Where will we place now our impedances and our gain? So our gain, so good lang ito sa gain. The gain is inherent or actually is it's an inherent, in term nga magamit, no? It's an inherent characteristic to our system. Butang na siya dito sa taas. So the gain of the amplifier will use the letter AV to denote gain. Usually A magud ang gain. And then because this is a voltage gain, so AV. Ang input impedance, again, I mentioned earlier that impedance is synonymous to resistance, meaning the unit, its unit is in terms of ohms. It's measured in ohms, ang impedance. Because it's synonymous to resistance, if another system or another device would look into this system of ours, it will feel the impedance as if it's a resistor. Okay, so where will we put our resistor? Right here. So this is the input impedance. Input impedance is denoted by this character, ZI, input impedance. So input impedance is the resistance that how will we technically define it, man? The resistance that is measured when looking into the system. Okay? I'll try to find a more accurate down this definition for input impedance. Naman din mga definition pero sa mga kayo. A more easier na definition aning input impedance is what if we connect a system here, that is the resistance na yang ma-measure. No? I guess that's the easiest way to look at it. The same with the output impedance. Output impedance is okay. Output impedance is this one. ZO. And I think ang gain, dire din na siya dapat. This is the gain of the amplifier. Output impedance is this one, ZO. It's the impedance or it's the resistance that is or that could be measured at the output na terminal. So, natin yung output impedance. So, ang gain is something that is inherent to the system, the gain. Okay, so this will be our model for our systems approach or systems point of view of a BJT amplifier. No? So, try to think na lang class na more yung pinaka-important for us. The input impedance, the output impedance, and the gain. Okay? Even siguro for electronic systems that are not necessarily amplifiers. No? When we say any electronic system, it could be amplifier lang magud ang atong naadli karon because this is the simplest to understand so far. But there are multitudes of electronic systems, no? Some of which dili na nato necessarily analyze because if we understand systems point of view to learning electronic systems, again, we do not need to know all of those as long as we know how to look at one particular system, namely this amplifier. No? So if we know how to analyze an amplifier, it would be easy for us to analyze all the other electronic systems. These systems could be a filter or an electronic filter or an oscillator or converters, switches, and all of those electronic systems. Pero ang amplifier mode ang pinakasayon, no? Masayon, yeah, honestly, masayon na ni siya i-analyze kaysa all the other electronic systems out there. So if we know how to analyze this one, it would be easy for us to analyze all the other electronic systems. And the same for all those other electronic systems. These three are one of the most important parameters that we should know, the impedances and the gain. So for actual systems, these are already given in the specification sheets. Na dito ang impedances ug ang gain. But if you'd like to know, and that's also one of the objectives of our class, we should know where they have obtained such values, and those values could be obtained using the ones that we have previously learned, using the parameters from the DC domain, namely the BJT currents and the voltage VCE. Okay. So I have here another set of table of formulas, this one. So this is a table of formulas for any amplifier configuration, whether it be fixed bias or voltage divider bias or an unbypassed emitter bias. So when we say unbypassed, notice previously that sometimes you connect a capacitor here sa RE. So for the unbypassed, there is no capacitors RE. And ako ditong uban, no? Emitter follower, common base, and collector feedback. So we'll just focus our attention to these first two, fixed bias and voltage divider bias. Okay. Mo na itong na-learn previously. So sa AC analysis, the fixed bias and emitter bias would belong in this category. Emitter bias. So this is for the fixed bias and the emitter bias. So under ang emitter bias, because our emitter the emitter bias configuration that we've learned so far is bypassed with a capacitor. So notice katong mga emitter bias na circuits nato na learn previously, naagid to a capacitor RC, capacitor C right there. So pag abot sa AC, magically mawala na siya because mabypass siya. Current will flow not anymore to the resistor but to the capacitor, in the AC domain. So current will flow in this direction na. And that's why nawala na si resistor RE. In effect, in the AC analysis, si fixed bias and si emitter bias is the same. So this will be for the voltage divider bias. And dapat atong voltage divider bias naagiapoy capacitor CE. So these are the formulas, at least these three are the formulas for input impedance, ZI, output impedance, ZO, and voltage gain, AV. Yan na. So we do not need to memorize again, and we will not derive anymore how will these equations be obtained, because actually class tedious yun ang pag-derive ana, maybe ma-bog down ta sa detail. Pero let's just state this as is, no? Nga mo ni siya ang mga formulas how to solve for the impedances and the gain for fixed bias, emitter bias, and voltage divider bias. Maybe gani sa ato ang kuan, no? Sa atong class, we'll just focus on this portion. Naka-purple na akong outline. Yan. So kanang uban na part, pwede na ito na i-ignore. No? Even sa akong other subjects, sa ECE majors, wala naman kayo mega bother o current gain. No? So kanang AI, that is current gain. Dili lang ta mag-focus sa voltage gain. And dili na ta necessarily mo gamit aning uban nga configurations, bypass, emitter follower, common base, collector feedback. So dili na ta magamit ana kay focus pud kayo ana gyud. So dili lang, no? Wala na yung atong i-focus gyud na to atong attention more sa 6 set of formulas, no? 3 for the fixed bias and emitter bias, and another 3 for the voltage divider bias. So if we know how to use these formulas, we'll be able to solve for the impedances and the gain this time. Okay. So if we'd observe, there are new parameters here na wala pa natin na-encounter. No, notice we have RE and RO. Wala pa man tayo undergo ana. So RE and RO. Muna sila atong siguro need na to i-define first, no, before we go further. Okay. So input impedance, output impedance, and gain. So we'll adopt a model for our BJT. For our type of analysis, we'll use the RE model for BJT AC analysis. RE model ang gamiton. Throughout the years, engineers have devised, at least electronics engineers have devised many, numerous models for the BJT. Kung gusto na to i-search sa internet, tingnan kayo na sila. But the RE model for me would be one of the most useful and most easier to use. Ito isa ka-popular nga model nga ginagamit decades previously. Ever small model man ata to. Then ay isa nga even karon mo gyapon lang standard ginagamit, which is the H parameter model. Well, in fact, if we refer to specification sheets of BJTs, it's more clear na H parameter ang model in mind sa katong nag-light sa atong specification sheets. But the RE model is more versatile actually, for BJT AC analysis. Why? All the other models, almost all of them are device dependent, no? So magdepende siya the time na gi-manufacture ang device or ang BJT. But for the RE model, it's more versatile because it is dependent on the external circuits. Versatile. This model, because this model is external external devices dependent. So in this case, at least the impedances and the gain would not necessarily rely heavily on the device itself, but on the external circuitry. So we've already appreciated this idea katong when we dealt with the stability of the DC configurations, diba, na ato na solve previously, nga voltage divider bias would be more stable compared to emitter bias, and of course compared to fixed bias, because no matter what value of beta we would replace our circuit with, dili kayo maapektuhan ang values sa circuit, no? So same for the RE model. The RE model, at least for the BJT, would be more versatile to effects to changes of beta, at least, no, compared to the others. So for the RE model, supposed to be sort of nagapon siya systems na approach to analysis. So this system sa taas, this is already the amplifier. So this is the amplifier na, which is characterized by the gain and the impedances. This one, akong gidrawing karon lang dayon, this is the device still, or the BJT. This is still the BJT. Okay. Kung schematic symbol, diba, the BJT is this one. Man siya class ang BJT nato, diba? Base, emitter, then collector. So this time we'll not use the schematic symbol for the BJT, but we'll use this one, another na systematic na point of view. So actually, kung ato i-compare, magmamawagya pa na no? So itong pangita na narga po na siya din. Hindi ko gusto mo sa'yo. Nala na siya. Diba? So the RE model. So naka-parallel si RO. Beta RE, current source of RO. So magmamaga po siya gitsura, di ba? Sa atong system's point of view sa amplifier. But this is the system's point of view of the BJT alone. So BJT lang siya. Meaning kung ato ning superimpose ang katong atong amplifier, na siya susulod sa atong amplifier. Okay, na siya susulod. Ang BJT lang ni siya. So this is beta RE. This is beta times RE. This is RO. This is sister light here, that's RO. And this is the current source. Current source, beta IB. Or IC, rather. So we could say that this is IC. This is more appropriate also because ato mangina think ang BJT as a current controlled current source. So na siya current source ato nga. Current controlled current source. So kung fixed bias siya class, or even if voltage divider, so external pa sa circuit ang atong mga kuan. So muna atong maybe I think this is the RB. Nato-disconnect ang RC. Napo dili ang RE. So So ang device lang gini siya. This is just the device, or that is just the BJT. So external pa sa iya ang all the other components. So let's define these newly introduced parameters. RE would be calculated as, so di na natin i-derive because I think we'll use calculus man to solve for the exact, or we'll use calculus for us to know how this was generated. Pero let's just state this as is. So RE is equal to 26 millivolts over DC IE. So that's how we'll be able to solve for our RE. And this will also work for any configuration. So as for you won't be needing to memorize many formulas. Pero I think this is one of the formulas na dapat memorize na nato. Kanilang, no? I won't need you to memorize all of these other formulas except that one. Okay. So kanila nato ni na memorize. Okay? Okay, pwede man mo mag-refer anytime. Kani sila. So kanilang. So RE, the internal resistance of our BJT is equal to 26 millivolts over IE. So fixed na siya nga value. Constant na siya. Much like 0.7. So RO. No? What is RO? RO is the device, which in this case is the BJT, the device output impedance. Which is different from the amplifier output impedance ZO, which will be calculated. Kaning RO, this is the internal output impedance of our BJT or our device. And almost always given. Okay, so given na siya. So no need to worry. And sometimes approximated as, if dili man galing given, approximated as infinity or a large value. And okay. Yeah, I think mo naman sila atong need na ma-learn for us to start using the RE model for BJT. Okay. So let's try to solve one example now. I think mo naman siguro wala naman siguro lain ba? If I could remember. Ako yung example na itong pwede ma-solve. Okay, fixed bias configuration. RC is 3 kilo ohms. RB is 470K. So beta is 100 and RO is 50 kilo ohms. So this time, solve for ZI, ZO, and A. Meaning class, ang endpoint ani is we're going to determine these values. So after solving for ZI, ZO, and AB, na lang tayo pwede replace ani ng mga values. So fixed bias configuration. Okay. So if we refer to the table here, okay, here's the fixed bias. To solve for input impedance, output impedance, and gain, yun sila. The output impedance you could solve easily. You could approximate to RC. RB, beta RE. RE. So we'll need to solve first RE. Sa RE. And to solve for RE, we need IE. So from the DC analysis, need ay gapon na mag-perform ng DC. So dapat tinato kalimtan to atong ipangbuhat previously. But at least, once masolve na to si IE, masolve na to si RE, and then masolve na to ang mga impedances. So from the DC analysis, first of DC sa una, pwede mo tayong mag-refer sa atong table sa kuan sa DC. Solve for IE. IE is beta IB. IB is BCC minus BBE over RB. So I'll use this one because it is fixed bias. VCC minus BBE over RB. So IB equal VCC minus BBE over RB. 12 minus 0.7 all over 470K. IB is equal to 24 microamperes. Okay. Next, solve for IE. Beta plus 1 IB. So 101, 24 micro. 0.43, more or less. Milliamperes. So that's IE. So we're ready now to solve the AC analysis portion. Starting with RE. RE is, again, 26 millivolts divided by DCIE. Diba? So, start familiarizing this formula, 26 millivolts over IE. So, RE is 26 millivolt divided by IE was obtained earlier, 2.43. So 2.43 milliamperes. So millivolt over milliampere is ohms. So 10.71. 10.7 ohms. Nasa may nga na. So once masolve na class, masolve na ito dahil eh. So ZI is RB parallel beta RE. Or, pwede lagi na siya actually class, oh, kung masatisfy ni siya nga condition. No? So, kung yan, duha ka set of solutions sa itong isolve, ano lang, diretso na lang tagamit ani. No? Mas accurate pa ganit ni. So, RB parallel beta RE. No? Kanil lang. ZI is RB parallel beta RE. ZI is RB parallel beta RE. So 1 over 1 over how much is RB given for 70K? 70K plus 1 over beta is 100 times RE is 10.7. Therefore, CI is equal to 1 over 470 plus 1 over 10 times 10.7. 100 times 10.7. So that's mga 1.07 kilo ohms or 1.1. 1.07 kilo ohms. Oh, you see, dol-dolo dayan, di ba? Tama po dili, oh. Approximately equal to beta RE. So kung diretso ta, we'll still obtain the same value. Bako lang mo kaya itong RB. So if you use the approximate na formula, we'll still have the same answer. 1.07 kilo ohms. About ZO, output impedance. Output impedance ZO is, I think it's approximately equal to RC na sa formula. Diba? Approximately equal to RC. So, diretso na ni. RC is given 3K. Diba? So, ZO is approximately equal to RC. Therefore, equal to 3 kilo ohms. Last, voltage gain. AV. AV is equal to, nagyapon sa formula, dala. Negative RC over RE. So don't forget class ang negative na symbol. No? So RC over RE. Capital RC over small RE. negative RC over small re, negative 3K over, what is RE? 10.7 ohms. Therefore, the voltage gain is equal to nasa mga 280. Wait, nasa. Okay, so voltage gain is negative 280. Unitless. So wala siya unit class. Kay gain man, no? I-multiply natin na siya sa input voltage to get the output voltage. So ang voltage gain is wala unit. So negative 280 lang. No? Right. Any questions?